Tunggu. Macam ni bintik.
Okay, ada. Okay, right. Okay. Yeah, can you all listen to me? Hello. Okay, alright. Right, so sorry for the delay, and we have a little bit of technical issue just now, and thanks to and thanks to our crew, so it has been sorted out. Right, let's chase back the time that we lost. Then, right. Okay, good afternoon, everyone. So it's been quite some time since my last session, maybe during October's. And yes, so without further ado, so we will just proceed through our session today. So so I guess you all know that for November and December we are having for our lunch learning session, we'll be more on the technical sessions. So for today, we will talk about the pressure regulators. So what is pressure regulators? But then before I proceed to our slides, maybe let's talk about something you guys interested in, which is pumping. Okay. Just in case that you guys didn't aware on this event, right? So perhaps now you should, perhaps now it's okay. I allow you to off my live for a moment, go to our Facebook page and like our page, click on BNB Seminar Hat. And then on and off, you will have a lot of updates on all of our lunch learning sessions, or the update of our company, or maybe some exciting event with all the rewards coming to you. Okay, so remember, so please like our page, and then you will know how to participate in this exciting event later on after these sessions. Okay, let's show back my face. All right, okay, so another thing. This one, fourth round of sound check. Okay, video check. Okay, so live check. Okay. Now I see my friend. Hi Andrea. Hi Ciao. Buongiorno. Okay. Right. So without further ado, so let's start with our session. So for today's session, we will talk about one of our products, which is the pressure regulators. So you guys might be wondering what is that actually? So it's okay. So thanks to our team, our Carraro team, so they have prepared us a very simple slide for us to understand what is this pressure regulators, and what is the function of it, and how is the design of it. So let's proceed to it. So so while we're showing the slides, right? So if you guys having any questions, so feel free to leave in the comment. So we will attend to you shortly.
Exclusive Turcom partner since 2011. Regulators and the superheaters. I would like to take this opportunity to give my best regards to all the friends of the Turcom family. In the hope to be able to meet directly again as soon as possible. And I would like to turn now to my colleague Matteo, that is going to introduce the fundamental of the self-operated regulators. Have a good lesson. Ciao.
Good afternoon to all. My name is Matteo Nobili, and I work in the sales department, and with Andrea, that's the sales manager, we take care of Asia Pacific market. It's a pleasure to be here, and I hope that the time we are going to spend here will be useful for you. So let's get started. This presentation is intended as an overview about topics related to our products, and more especially about regulators, which are currently our best seller. In the next training session, we will also talk about other important products such as the superheaters. Since there are not only technicians amongst you, it is the purpose of this work not only to know the regulators, but also to understand their application and in which markets they are engaged. The Carraro production is divided, as you can see in this slide, in three main product families: regulators, desuperheaters, and safety valves. Regarding safety valves, pay attention because we have only UV stem for lube oil application. So, as already said, now we will focus our attention on the regulators. The general concept presented here cover all types of regulators supplied by Carraro. Some models are going to be discussed in great detail, so let's start to say what a regulator is, and in particular what is a self-operated regulator. The regulator is a self-contained mechanical device which is activated by the fluid flowing through it, so it's the process fluid. It's a device whose primary function is to match the flow of the medium flowing through it to the demand for this medium placed upon the system. At the same time, the regulator must maintain the system pressure within certain acceptable limits. They represent essential and crucial items for an adequate control of the pressure in the plant and fine application, especially in markets like oil and gas, power, chemical and petrochemical, and general industry. Carraro regulators are suitable each kind of medium, dangerous and not dangerous, like for example oil, aggressive fluid, steam, air, gas, water and liquid. Regulators are made up of three essential elements: a restricting element, lowering element and measuring element. They are all mechanical components, so all the regulation is mechanical. Since the regulator's job is to modulate the flow of the fluid into the system, we can see that one of the essential elements of any regulator is the restricting element that will fit into the flow stream and provide a variable restriction that can modulate the flow of the fluid through the regulator. The slide shows a schematic of a typical regulator restricting element. That's for globe valve is the trim composed of seat, the disc and the plug. It operates a variable restriction that can modulate the pressure and consequently the flow of the fluid through the regulator. In order to cause the restricting element to vary, some type of lowering force will have to be applied on it. Thus we see that the second essential element of a gas regulator is a lowering element that can apply the needed force to the restricting element. In our case, the combination of a diaphragm actuator and a spring, as shown in this slide, forms the most common type of lowering element. The spring provides lowering force to move the restricting element. The last element is the diaphragm that works as a measuring element which tells us when regulator flow is the same of user flow. At the variation of the pressure, the diaphragm compresses or releases the spring to deliver more or less fluid into the system. It's important to understand once again that pressure regulator not regulates the flow, but through the variation of the pressure we measure the variation of the flow, because the controlled pressure and the flow rate are linked together, thus changing flow, changing pressure. This example illustrates that there are three essential elements needed to make any operating gas fluid pressure regulator. They are, as already seen, a restricting element, a loading element, and a measuring element. Regardless of how sophisticated the system may become, it still must contain these three essential elements. But why use a regulator? Engineers agree that the simpler a device is, the more reliable it is. Every component has a probability of failure, and the probability of failure of a system is the sum of all the probabilities of its components. The fewer and simpler the components, the lower the failure probability. Regulators are simple, so they are cheap, and they require simple maintenance, so they have low serving cost. Regulators are self-contained and self-operated control devices. They don't need any type of external power supply, transmitting instruments on control instruments. Regulator speed of response is quicker than a control valve that for some application cannot react fast enough to the change to avoid potentially serious issues during the operation. Finally, self-operated regulators are suitable for all those applications where the set point is mainly constant over a long time during the operation. A possible deviation of the control pressure is acceptable. In this slide, you realize the main difference between a regulator and a control valve. Note that in the common feedback control loop, in addition to the control valve, a pressure transmitter and controller are required, as well as an external power source, either air or electrical. With the pressure regulator, the process pressure supplies the power, and the regulator becomes transmitter and controller in one device, a much simpler, cheaper alternative, always when the process allows. So, in way to recap and be more clear about the difference of a regulator with a control valve, we can see here a quick comparison. You can choose a regulator because it's self-contained, has a fast response speed, is a simple device, is compact device, is easy of installation and easy of maintenance. This slide shows us why for our regulators we can say install it and forget. As already mentioned, our regulator is self-activated. It's activated only by the fluid passing through it, so it's not necessary any external source, power or signal connected to the distributor control system. So in this way you can install it far away from the plant and is able to work for many years without any special maintenance. I will start with a brief terminology section dealing with regulators and process control. We start looking at the main types of regulators, obviously directed, operated. Pressure reducing regulator. It's a valve that satisfies downstream demand while maintaining a constant reduced pressure. Back pressure regulator. This is a device that controls and responds to change in its inlet pressure, usually operates open. Pressure relief valve. This is a valve that opens and closes to ensure that pressure does not rise above a predetermined value, usually operates closed. Pressure relief valve is actually the same device as a back pressure regulator, but with a different purpose. They both regulate the upstream pressure, but while the back pressure has the throttle, The relief valve has to open at a certain set pressure, similarly to a safety relief device. But pay attention, a pressure relief valve is not a safety relief valve. They have different way of working, different standard and different purpose. A safety valve is the last protection of the system and has a pop-edge function. Now we are going to see in more detail a pressure reducing regulators. Pressure reducing regulator maintains, as already said, a desired downstream pressure while providing the required flow to satisfy the low or user demand. This pressure maintained by the regulator is the outlet pressure setting, that is the set point of the regulator. Direct operated regulators are the simplest devices available for downstream pressure control. They are available with internal or external pressure sensing and can have a flow to open or a flow to close design. Direct operated pressure reducing regulators can be designed only with a spring to open layout, so the only possible failure modes are spring failure, regulator will close, and diaphragm failure, in which regulator opens. Thanks to this slide, we can imagine what happened in a pressure reducing regulator. When the downstream demand increases, the downstream pressure drop and the pressure on the diaphragm drop, so the system became unbalanced. The spring pushed the diaphragm downwards, causing the restricting element to open and thus delivering increased flow. Otherwise, when the downstream demand decreases or stops, the downstream pressure increases. So the pressure on the diaphragm increases, and the system is once again unbalanced. The spring is compressed, causing the restricting element to move up, delivering less fluid or looking up. Now let's see in detail relief and back pressure regulators that are the same devices. The different name is determined only by the application. Starting from the relief valve, a pressure relief valve limits pressure build-up, prevents the overpressure in a system. The relief valve opens to prevent a rise of inlet pressure in excess over a desired limit. The pressure at which the relief valve begins to open is the relief pressure setting. Otherwise, a back pressure regulator maintains a desired upstream pressure by varying the flow in response to change in upstream pressure. The upstream pressure maintained by the regulator is the pressure setting, the set point of the regulator. Now let's see again what is the set pressure in a relief valve or in a back pressure regulator. In a relief valve, the set pressure is the pressure at which the relief valve begins to open. In a back pressure regulator, the set pressure is the pressure at which the regulator supplies the requested operating capacity. Remember always that relief valve is not a safety relief device. We can see now in this slide a schematic example of a back pressure regulator installation, and in this case it regulates the pressure from the pump to the tank. And in this slide we can see once again the main element of a pressure regulator, and we can see that the main mechanical feature that defines the nature of a regulator is the behavior of the spring related to the trim. In a pressure reducer, the spring pushes to open the valve. If the spring acts too close, it's a back pressure or relief valve. Now, thanks again to this animation, we will try to understand in which way this device works. When the upstream pressure increases, also the pressure on the diaphragm increases. The system became unbalanced. The spring is compressed by the diaphragm, causing the restricting element to open and thus deliver more fluid. Otherwise, when the upstream pressure drops, also the pressure on the diaphragm decreases. The system becomes once again unbalanced. The spring pushes the diaphragm downward, causing the restricting element deliver less fluid or looking up. Shown in this slide that is in common to relief back pressure and reducing regulator is that on the top of the diaphragm there is the atmospheric pressure that in this case is the only reference pressure. And after this slide we can start to talk about the last function of a pressure regulator, that is the differential pressure regulator. In fact, a differential pressure reducing regulator maintains a desired downstream pressure with respect to a reference pressure other than the atmospheric, while providing the required flow to satisfy the load or user demand. Otherwise, a differential pressure back pressure regulator maintains a desired upstream pressure with respect to the reference pressure other than atmospheric by varying the flow in response to changes in upstream pressure. According to the two descriptions given above, the two types of regulators operate as the regulator as described previously, but instead of having as a reference the atmospheric pressure, they can have reference set pressure to the pressure in a vessel or in a pipe. This pressure maintained by the regulator is the setting of the regulator, the set point, and it's relative to the reference pressure. It's not a gauge pressure as usually referred to. The failure modes are analogs to the previously described relative to the pressure reducing and back pressure regulator. In this picture we can see how a differential pressure regulator can work. We can see in red color the upstream pressure, in blue color the downstream pressure, and at the top of the diaphragm we have in green color the external pressure reference to another pipe or a vessel. In this case, the differential pressure between inlet-outlet and other reference line in green is the set pressure maintained by the regulator. In this real image you can see the two pressure sensing for a differential function. In this example you can see the required connection that are one on the lower diaphragm case and one in the upper diaphragm case, that is the external pressure sensing that goes in a vessel or in another pipe. And now we can introduce another concept, that is the pressure sensing, that can be external or internal. The difference is simple. In the first picture, the valve pressure sensing is internal. As you can see, there is a small channel that connects the lower body to the actuator chamber under the diaphragm. So the valve is able to relieving the outlet pressure internally. Instead, in the second picture on the right, the pressure sensing is external. You can see the channel tapped and external tubing connecting the lower diaphragm chamber with the piping. We are able to select both solutions, and this depends on the specification requested by the customer of this product or by the fluid properties. And these last slides show two real photos of the Uban series, that is a pressure reducing valve installed, the first with internal sensing and the second on the right. You can see the piping with the external sensing pressure. For today it's all. In the next presentation we will see better in detail our regulator product range, and at the end, in the third meeting, we will see our desuperators. Thanks to all for your attention. Have a nice day. Bye.
Okay, right. So yeah. So thanks, Matteo. Thanks to Andrea for sharing this slide with us. And I believe that you guys have learned a thing or two about the pressure regulators. And okay, so well, I see from the comments, right? So maybe I'll just pick two questions that that just I doesn't like to that the answer. So the first question is from Abdul Hakim. So he's asking whether the blood pressure and also relief valve are actually the same thing or not. So basically, for pressure regulator, first thing is that pressure regulator is different with pressure safety valve due to their functionality. So in terms of blood pressure and the release, so basically they are designed and the mechanism are same, just that their application on site there are a slight difference. So next one, proceed to the question by asking whether any difference in terms of internal and external sensing. So about this question, right? So yes, definitely there is. So because as for some application, client actually they just want to regulate the pressure. So as standard, we will propose them those with internal sensing, which you are actually measuring the differential pressure at the valve itself. But sometimes there are some application client actually requested to have the external sensing, which is the tapping point is at some point at the downstream. So at those applications, right? So we will offer those we will offer the regulators with the external sensing. But then bear in mind is that one thing, if let's say client or maybe in certain application that require to have the external sensing, so at the pipeline there must be a tapping point in that for us to be able to get the pressure as the reference. Right. Okay, so I guess yeah. So I guess that's all for today. Just that another reminder again. So please follow our group and stay tuned for the announcement of the exciting evaluators. Yeah, I guess that's all for me today. So yeah, thanks for your time, and really sorry for the technical issue that we have encountered just now. So stay tuned for the episode 2. So I'll see you again. I'll see you all again on next Monday. Okay, bye. Ciao.